All right, we're back. We are back, and we are going to do some sheet metal design. Got some parts back this week from the streams we did last week on the other version of the tumbler, the first version, and looks like this. It's not bad. It still could be better, and we're going to do that with some of the changes we've already made. Specifically, you can kind of see the bowing here. That is an artifact of the super small radius of this bend here. And so already in this CAD, you can see we've increased that bend radius. But this is going to go to an old version of the part tumbler. The one you see there, that's just to get that functional and working. So that version's already done. This is just a part of an improvement suite we're performing on that because although it works, it could work a lot better. So there's some low-hanging fruit there we should pursue. But for this version, this is the much cheaper, cost-reduced version that we built the first prototype of and still needs some refinement, specifically for things like that bend radius, but also the things on this to-do list here. So the goal is to speed through this and get this next prototype made. Once we do that, we'll pop over here and finish up the CNC / 3D printed version of that. I've already got the parts made. I'm looking forward to getting this one built, but I want to get the sheet metal version finished first. It's very exciting. What am I forgetting? I went through and built this, and it worked. Interestingly, small digression, but it worked. But it failed right here, and it failed interestingly in a way that I wasn't presuming. It actually failed through tear-out rupture of the threaded sort of stub coming out of this feature here. But otherwise, some weird artifacts with mirroring threads, but otherwise it worked, which was fun. So that was for the bike holder thing that I was working on last week. Anyways, back to the tumbler. Interestingly, yeah, I mean, just a note, if you're mirroring threads, be careful. You really should never mirror threads if they're actual threads you plan on machining. It's a no-brainer, but when you like to work in sort of half of assemblies and mirroring them, it'll bite you, as it did for me. So just a heads up there. All right, so we're gonna get back to this. We're increasing the barrel diameter to assist with the forming of the sheet. So it's that sort of concavity thing I was talking about earlier. And then we'll just get cooking through the rest of this list. I actually have some new motors here, which we're going to implement as well. This one from Servo City just delaminated. It just destroyed itself instantly once I over-torqued it, which is really surprising because, I mean, they specifically sell motors for this application. And you know what's funny? We actually in the calculations realized that it was going to do that. Oh, wait, I got to share this. I forgot. Duh. It's funny, you have to share this, you have to pretend to share it once. Fake X into thinking you're not going to post it, and then it will post. Yeah. As I was saying, we are going to increase the diameter of this barrel, and then we'll get cooking through the rest of the list here. we just join this? Looks like I could for some reason. There we go. Oh yeah, the motor. So the motor exploded, which is funny because I didn't exceed the torque. Which is, well, it's not funny, it's annoying, but it's funny. It does validate the calculations we made. And we found out that the motor shaft would fail before the motor would fail. And it turned out that the opposite happened, interestingly. But either way, the motor exploded. Counter to that, the previous version worked well. So the motor from this version was phenomenal. I mean, I actually stalled it out once the hatch failed, and it behaved nicely. It just sort of stalled and didn't complain, didn't really burn out. I got it running again, so I think I'm going to stick with this motor manufacturer. We're going to step back away from Servo City and come back to this one. The downside is that the packaging is a little off, and I think it's a little pricier, but oh, and availability as well. Sourcing this outside of Amazon was a bit of a challenge, but I'm sure we can find some way to get it sourced. Yeah. So anyways, let's get back to it. So we need to get the hatch here installed. This one. So see if we can find a way to quickly pull that geometry out. Actually, I don't think there will be. I think we have to brute force this. So I'll just roughly measure what that geometry was. So the distance from, say, off center what this was. And it looks like it was something like 2.5 millimeters. Is that right? Find another way to measure this. Not playing nice. Let's see if we can measure from here to here. 2.4. I want a center measurement, but it's not going to work. So this was an M4, I believe. Yep, M4. We'll copy that. So how are we going to model this? I think we're going to copy the same method that we were doing over here. We might actually be able to just mirror this geometry over. That would be awfully... Actually, we can do it right here. That'd be awfully simple. You can make that work. Let's get a mid-plane here to mirror about. I don't think this is going to work, but it's always worth trying because they've been adding new features that have made this easier. So that's not going to work, but that's okay. What we'll do is we'll mirror that anyways and just pull the geometry over. The body, that is. And how are we going to do that? Must be a way to brute force this. So we'll subtract from this. We'll subtract this. Keep the original, or keep the removed body. It's not playing nicely though. Why is that? What's going on here? Going to see if I can just create some planes to slice this geometry with. Do the same over here. Definitely a case of do as I say, not as I do. This is pretty ugly, but it's fast. Okay, so we have this tab now we want. Put that back. It's actually kind of in a perfect position, but we probably actually we want to get this. We want this face to line up with this face essentially, so we still have a little bit of rotation to do. So I wonder what this dimension is. Hopefully it's a nice even like 5 degrees. 7.5. Love it. So we can actually snap that at the center point and rotate the 7.5. Looks like that was the mid, so we actually have to do that. No, I don't know what was that 7.5 degrees then? Just an angular measurement, but why would that not match? Confusing. Very confusing. Let's see. Three's almost there. It's 2.5. I don't understand that, but okay. And then how far are we off from this face? 6. Just pull that in 6. That was easier than I was worried about it being. We'll clean this geometry up. So we actually want to subtract these bodies, but I wonder if we can pull those faces from this. No. How would we do that? I thought this would be easier to do, but it ended up being a shortcut that's costing me more work than I would have liked, but I'm already here. Let's just... Actually, I want to learn how to do this. Let's find out what I'm doing incorrectly. Actually, let's just slice this. That's the fastest way. So I'm going to literally just use this. Use the fancy new select through tool and just slice this. Except I'm going to slice this body. Yep. And then this one actually, yeah, there we go. There we go, look at that. Not a single sketch sketched. Cheated my way through it. I mean, knowing what I know now, I did this the long way. I don't think I would have done this again, but it's fine for now. So let's actually pull this tab into place. That was, what was that distance? You can measure just from there, really, 5. Okay, so we're gonna move this 5. Hopefully. Almost. These faces do not want to move, and I don't understand why. My gizmo's not snapping the way I want it to. A lot of frustration there, but yeah, why is this gizmo not snapping? Weird. The reason why these tabs are a little bit longer here and they look off is because we're going to hand bend these and we want that extra meat to be able to get that hand bend nice. Because you're going to push on this tab to do that. Okay, so is that roughly the same distance away from the edge? I mean, it does look like it. I think it is. So that's good. And then we have our rib here. I think we're going to hold on to that. We do want to change the diameter though. I was hoping we could avoid having to redraw that. We'll see. So this hatch is becoming pretty real. That's good. Let's see what we get out of radius. I forget what my internal radii were. I can measure it. Don't know that I have a good one though. Okay. What else? So we want to get, I think we want to get this hatch modeled now. I think that's the move. Another thing I want to do is add some effet holes here. Effet holes are just holes that aren't used in the first prototype, but you put them in assuming that if it doesn't work, you can bolt in another solution. So they're effet holes, because effet, why not? I can't say the real name on stream or else I will get the video delisted. So complain to your nearest tech CEO about that if you don't like that. Actually, I can spell effet differently. There you go. Now you know what it means. Okay. Hatch. Let's get this hatch in. Is there a quick way to pull this hatch in and scale it? I don't think you can, because this is made for M4 hardware, and if you do a global scale on the part, those dimensions are going to go all over the place, and they're not going to match what the actual hardware needs to be. So we won't do that. So we will do this the correct way, as much as I hate to say it. There might be an ugly way to do it. A fast way to do it, I should say. Let's get this modeled as like a radial. Let's get this modeled against actual radial faces for one. Maybe we can extract these features out radially. Actually, that's the way to do it. That's what we're going to do. We're going to get this aligned radially, and then we'll just pattern it out. That's going to be the fastest way to do this, I think. So, curious, how off are we from, I snap a plane right there. How off are we in terms of revolving? 135? So if we revolve this 135, this, wait, what's going on? Why is it doing that? Oh, 135, so it's the complement of that angle. So it's 135 minus 90. That doesn't look right either. So what's going on? Why was that 135? 155. So it's 65 degrees off, allegedly. Looks about right. Is that right? It's hard to tell. I think it might be right. It is right. Look at that. Alright. Saved ourselves some work. So we'll clean up some of this geometry actually first. Where'd it go? So let's do, I don't know why my view is exploding here when I snap this. Let's just draw a sketch and extract the geometry we want. So we're going to do, oh, right, why not there? So just mirror that over actually. It's easy enough. And then we'll delete this. Okay. And so now we can snap that to the mid and then get this into a position that makes sense radially. There's our edge of the hatch. So I think we do want to do that. That's fine. I think that's good. But actually, first, we want to get this positioned radially correctly, because remember, we moved this out, I think it was 25 millimeters, because we grew the barrel by 25. So this should move in the right place. And it does. This radius is off, because that obviously makes sense because we changed the outer radius, but we can quickly fix that doing this one simple trick that parametric modelers hate, which is to slice your bodies. And that looks right. So now we can go back and pull this in. So now that's looking realish. I think we actually might want to pull it in the thickness of the material though. Actually, I know why this is breaking now, because I need to hide these. There we go. And now my view is fixed. So let's get a section back and let's see if this makes sense. We actually want to bring this in the thickness. I picked the wrong face. Actually, we can fix this by just going back in the parametric history and reselecting the slicing face. So we selected the outside. If we select the inside, that should actually change the geometry in the way we want. Face, we actually want this one. And it worked. Look at that. Okay. So now we can clean this geometry up with some healthy radii on the outside. We decided on just do 4 and 2 from now on. So now we want to, dare I say, mirror this to the other side. Looks like it doesn't play well with this tab there. As a matter of fact, we should actually get that hardware in there while we model this so we don't mess this up. So I think we want, where did I take that hardware? There it is. Remember, we mirrored that over. We're going to kill the copy on that. And it ended up somewhere I was not expecting, but that's okay. So we will pull this in. Actually, I think the mating hardware, the mating face is going to be on this side, so we're going to adjust that. Now, we already see the issue we had, which is getting that hardware in is going to be difficult because of this part. So let me join these two. That's funny. Just for giggles, if we chamfer this, can we actually get that out of the way? Yes, but it's still a pain. Getting to that bolt head when this hatch is engaged, or when you're installing this hatch, is going to be kind of a pain. So we could put a hole in it, but that doesn't really fix the issue. See what I mean? We could do that. But then getting your hand in like that. What I'm trying to do is make it simpler to install. So right now, what we're looking at is this barrel. And you're gonna have to reach in like this, and you're gonna have to hold on to this hardware. I can actually see that I did this previously, and it was kind of a pain. So we could just rotate that out of the way, but we do want that radius to be continued down. So I don't know what exactly the best solution here is. Guess we could just get it out of the way. And this might just be a case of saying, yeah, this sucks, but it's the solution. We might just be saying that. Which you're only allowed to do sparingly. Should not be the default. Usually it comes with buying the machinist a six-pack. But that does work. Sometimes buying Dave or Diana a six-pack is easier than doing your job well. I think this is going to be okay. We're going to have to, yeah, I mean, we're just going to reverse the hardware here. Do I need this still? What is this? Move this down and see what it is. Yes, I do need it actually. I think this is what I don't need anymore. Okay, so we're going to reverse this hardware and then forget about it. That barely fits, but that's okay. Now we want to get this hatch in. We want to give that a radius so that it doesn't interfere. Like a glove. And actually we want to offset this too, just for clearance. So we'll give it 2 millimeters all around. We're just trying to make sure that media and parts can't get out, which is, that'll be plenty. Actually, you know, maybe 2 is too much. Maybe 1 millimeter and see if that causes us any issues. And then on the back here, we'll have to do the same. Here, actually, I think that gap's gonna be simpler. Actually, let's look at the gap of what we did in the previous design. So this is revision B, and let's look at the official release. So this was it's on a different radius as well, so that might have an impact here, but it was roughly 4 millimeters. We can double check our clearances once we actually get that modeled. So why don't we do that right now? We'll bring this in 4, and then we'll add our radius. I think we said 6 on this one. It was 6. So I'm going to change this real quick to 6. Okay. And we'll also have to model that bend. So actually this was a redundant radius. I should have done that. So just while we're here, let's look at how this interaction is going on in the back when you rotate this. So I'm going to move the pivot point to the screw head. And when you rotate it through, it should just kiss, but really not interfere. So that's happening, which is good. Okay, so a couple things. We want to get this bend modeled onto this side. And then we want to get the neglected stringers modeled correctly. Did I delete this? I didn't, I just hit it. So let's get a section. And let's get this rib / stringer modeled correctly. And the easiest way to do that is going to be something like this, I think. These are both wrong. So these are really wrong. I'm going to do this really ugly. And just sketch on them and take away the material that I don't want. 200 sounds nice. Okay, looks decent. Okay. And then we want the radius on the outside as well. 4, and this should be 4. I think we decided on 4. Yep. Okay. So that's our stringer. What was our rotation on this? We're going to need that for the hardware here in a second. Okay, we want to get this tab modeled in now too. And did the polarity of this offset go incorrect? Looks like it did. Weird. Where was that? There it was. Great. So now we'll pull this over. Just do some ugly slicing like I did earlier. And I might actually step back in time and go find where I made this tab. And then just pull a copy of this over real quick. There we go. So now I can salvage this. And so, let's see what this looks like. You just isolate these bodies. I should pull this in line. How far off are we here? Some weird distance. It's because of that offset. But how if I move this? See, that broke my radius. I don't think it did. Okay, we're almost there. Slice this up. And I think we're golden. Almost. This got butchered, but we can fix that. Nope. Still butchers. What's going on? I think we slice it about its geometry. There we go. Now I can join all of this. This is still slot, but I remember it was 5. So I will fix that. Do the same here. Same issue, it doesn't want to follow that. I wonder why. It's those faces, they don't want to play. We'll never know why. Let's see if that matches. And it does. Great. Typically you want a bearing there, or some, well, don't know if you would call it a bearing, but some type of bushing there just to provide a better riding surface. You'd want something like oil impregnated bronze bushing. The reason being because this is going to be stainless on stainless, and similar metals have a tendency to gall when you mate them tribologically, which is to say you put them together and then move them relative to one another. Is tribological a word? It is. Anyways, tribology is the study of material interaction, fundamentally, specifically in mechanism design and dynamic environments. And so in this case, we have the hatch moving relative to this, and so we want to ensure that the materials that are mating are compatible. Technically, they should be incompatible, which makes them compatible. But I'll leave that there. So this is roughly what we need, but I'm not going to spend 14 bucks on this. So we'll cycle test it. I think it'll be fine. Let's get this hardware in and draw these holes for that hardware. So best way to do that is going to be, let's see. Ooh, I just had an idea. It'd be great if you could do PEM hardware inserts orthogonal to the sheet face, like putting it in here like this. Right now they can't do that, but it'd be nice if they could. What if there's a reason why they wouldn't be able to do that? Also, can you radially insert pen nuts? No, you can't do that. Same problem. So this is the hardware we need to pull over. I think we found, was it 45 or 55 was to get orthogonal? Looks like 45. Now we wanted to, next, how did we do that? I think we did it this way. I think I'm going to just move it relative to center, which was there, and then we pull up the 45, I think we said. Yep. And then we moved it to 25, which is what we grew the barrel by. That should put it right where we need it. Yep, about. Almost, but good enough. And then we can move it to its new position, which is at 55. And then we can mirror that over. Love a good mirroring. Really simplifies things. And then we'll take away that hardware. So there we have our holes. And then we'll give ourselves a little clearance. Actually, not only do we want to give ourselves clearance, we want to give ourselves clearance on this. Then we want to slot this one. That's what we just did on the new prototype. And the new prototype liked it. It worked really well. So you can actually see that slot detail here. And it helped a lot on the install. It was still a bit of a pain to install, but it was better than nothing. So yeah, that was much better. So that in combination with the increased diameter should really make this much better. But how did we model that slot? I think we did it the ugly way. Did we? Might have just sketched it. Actually just Yeah, I think we just sketched it, so that's what we'll do. So it's going to be this, and we picked an arbitrary angle. It's probably going to be 5 degrees. Then I think we said, what else? Oh, we need to get center for that. And this center was 45 off, or was it 55? I think it was 55. That should be on the center of that screw. Looks like it might be. New body, and then we'll get this. Actually, what's the fastest way to do this? I really do think it might be creating a plane and redefining a plane for that sketch, but we'll see. So we'll make a plane, center point, parallel to face, pick this hole. Ooh, can't pick the whole center because it is a NURBS curve, or NURBS surface. It's not just a canonical geometry, as the nerds would like to say. What is that distance? Maybe that can help. No, how are we going to get that sketch there? Well, I know it's a 4.25 or 4? It's a 4 millimeter. So maybe we'll get the minimum distance and that'll spit something out. So we're looking for delta y. Delta y is 61 and some ugly number, so that ain't gonna work. Huh. Maybe we can use this. It should be at the center of this, right? And it is. So it's going to be at the midplane of these two. So now that distance is something hideous, but that's okay because now we can redefine that sketch that I used to create this on that corrected plane. So we'll redefine that plane here, but I have to pull up that midplane first so that it makes sense in the build order. So I will redefine that sketch now. And it explodes. That's fine. We're going to change this to, what size? I have no idea what that is. It really exploded. I think it's because the orthogonality of that plane flipped. The edge is no longer in the plane. Which edge? Tell me what broke. What broke? Okay. Okay, good enough. We want to flip this extrusion into a symmetric, and then we're going to divide that by 2. It's not symmetric. And now we take this away. So here's a little trick. If we fill up these, we'll get our slot. So it'll be 4.1 divided by 2. Look at that beautiful slot. Subtract. Boom. Look at that. Great. So that's in the right place. That's in the right place. We have this slotted. We are good to go. Might be a little too much slot, but I don't think it really matters. I think this hatch is pretty much done now. All right. So we're gonna add effet holes. And what else? Increase the length too, because I think we wanted to get this sample in. Right now it doesn't really fit. Let's test it. So I'm going to insert this. From the top. So to do that, I get rid of that. Get rid of these. So I'm going to simulate trying to get this in. So I'm going to rotate it like so. And I'm going to pull, I'm going to drop it in, move it over a bit. Does that work? Yep, still good. Yeah, but then you hit there, so you can't really get it in. So the size of this hatch essentially has to be the size of this part. What I'm doing here is I'm just measuring. I actually want to try to fit this part into my new version of the tumbler. So it's telling me I need a 300 millimeter wide hatch essentially, which might be feasible. So right now we are at the length we figured out is a thing, but right now we're at 136. There's 272, and I think the max sheet size was, we're going to look at it. So we're actually limited by the width here, I think. 44 was the, yeah. So we're limited by the 30-inch dimension now. Or were we? I think we said 2 pi, no, it was pi d. The diameter is 225. What was the diameter of this? 250. So we're at 785. So 30 inches. We're just above the 30 inches. So we have 700. Right now we're at 136 times 2, 270. Yeah, so we can make this 3 times longer and we're still fine. So we're good there. But this does need to increase in size. So this needs to be 150 essentially. So we're going to have to extend this entire assembly essentially. And we'll do that. First though, let's get well no, let's just go ahead and do that. So distance from here to here needs to be 300 and I'm sorry, 150, and right now it's 100. So we need to increase that by 50 millimeters. Which is going to be 100 overall. So that means I'm going to move all of this over 100. And then these faces as well. I'll move 100. Take that parametric modeling. How easy was that? And we'll move this to 100, like I said. I'm sorry, I said 50. 50 per side, 100 overall. So this comes over the 50 as well. So now, that's our new mid plane. If I mirror this over, this should play nicely with that bearing. Just as a sanity check. And lo and behold, it does. So double check, pull a section here. Yeah, nope, wrong side. This side. That does play well. All right, so our symmetries are still existent. It makes sense. We actually don't want to mirror this part. We will, because I happen to know that symmetry is definitely existent, but you want to be careful when you do mirrors like that, because this part might not be symmetric in the way that we expect it to be, which would cause us issues. But this is a 2D flat cut part, and I happen to know that that means it's symmetrical. If it wasn't, then when you went to go make these parts, they wouldn't match up. This would not be what you needed it to be, but I happen to know that they are indeed symmetrical, so we're good. So we'll start mirroring. We're going to save a copy here in a second, because I think we've made enough progress. And that is our part tumbler barrel. Much bigger than last time. I think we're going to have to check clearance on this. But anyways, let's see if this will actually fit. Barely. Ta-da. But it does. So I can actually get this part in there. That part has been my litmus test, as I said, for what the size of the hatch and the barrel need to be. All right, we also need that hardware for mounting this, so I'm going to copy that over as well. And I might actually just really quickly do this the ugly way, which is to, you know what I ought to do is get this symmetric now about the barrel on the XZ plane. It's going to simplify my modeling. But it is going to move a lot of things, but that's okay. So let's actually take a step back and see what that new distance is. It's not a perfectly round number. But I wonder if we go ahead and move all this, that distance, what do we get? So it's 76.2525. Let's see if that actually gets us a round number. What I'm trying to do is just create symmetry about both planes, both my XY and my YZ and my XZ plane. So this is XZ and this is YZ. And obviously we won't get it about XY because the bottom isn't the same as the top. So let's go ahead and measure this distance now, and if it's not 0, it says it's 0, so maybe that's what we're gonna do. Let's see what this mirror op does. I mean, it looks like it might work. That's gonna simplify the modeling a lot. So let's do some sanity checking. That Y delta is 186.5225, and this should be 186.5225. It's 186.5226, so we're off a tiny amount. So this wasn't really worth doing. What I will do instead, though, is generate our new midplane. And to be extra careful, I'm going to use parallel to face and pick up the world coordinate system. We'll call this barrel midplane. Okay, and then we'll step back to the end of our history. Should work. pull that hardware back. So I'm actually going to pull the PEM nuts as well, and I'm just going to pattern them. So we want that midplane. And I have, what is it, 6? There we go. There's our hardware. Let's go back and see what we're doing here. What to do. So the barrel's pretty much done. We just need that latch and the effet holes. Attachment flange screw holes. Access hole for frame connection screws. I think we actually got around that by changing these to PEM nuts. Yeah, we did. So that's solved. Let's make a copy like I said. So we're on B. C. We're on B. No, we're on BD. Clear my history. Okay. We already know this fits, so I can delete it. All right. So latch. We need that latch feature back. It was a flexure. So we need to bring that back. The idea is that you pull this down and you would slide this tab into, or you would slide this arm into the tab here as a locking fixture. And didn't really work. But that was largely because the barrel construction didn't work, not because the flexure didn't work. So I haven't given up on it yet. And as I said, we'll add some effet holes to bias an alternative solution should it come to it. And we don't want to wait for more parts. So what are we going to do here? I think we're just going to copy that design, but what's the fastest way to do that? Actually, before we do that, let's clean up the assembly tree. That's what I'm going to do. So all of this is barrel hardware. And this is the barrel itself. So this was, what do we say in terms of thickness? 318. So let's fix that. And then we'll pull these two in. Is that right? Yeah. Okay. We have the actual wrap itself. We've got some artifact that I broke. That's fine, fix that. So we have, I think, the hatch now. Yeah, we have the hatch and the wrap. So let's just bring this back. This is hatch. Yep. And then the wrap, I think we had it down here. Yep, there it is. Okay, that's all cleaned up. All right, this flexure latch. Back to the flexure latch. What are we going to do here? So we don't need this anymore. We don't need really any of that. I think we will hold on to this for now. That's just the piece that you hold on to make it easier to manipulate. But we do want to extend this. Modeling this was tricky. I think we had to do some radial calculations on this, which was kind of annoying, but we had to do it. So let's think through some of the decisions we made. We'll draw while we do that. So the idea was we had this tab, this long tab that came out and had a little bend up, so that way you could slide it onto the receiver here. And we actually changed this receiver geometry a little bit. It's actually a little bit shorter last time. If you'll remember, we actually ran the FEA on that and got into a place where we felt pretty good about it. But this might be a case of we just leave the design alone, because we weren't really able to invalidate the first version of the design, specifically the design of the flexure locking tab on the first iteration, because we had so many issues with the barrel wrap manufacturing method to begin with. So we might just leave it as is, recreate it, and we'll see what comes out of the other end. We might do that. I mean, what are the alternatives? Maybe we'll add the effet holes, and then we'll release this, and we'll get a secondary latching mechanism prototype, not prototype, but designed so that by the time the parts get here, we can have an alternate solution as well ready if the first one doesn't work. That would make me feel better. Thinking further, what does that buy us? Ideally, the secondary or the alternative version of this would still be primarily sheet metal and wouldn't necessarily be a CNC'd or cast part or stamped. Actually, why can't it be stamped? So Pete Holderith on Twitter has done a very good job of figuring out stamped parts, and this would be a prime candidate for it. But I would argue specialized tooling for an open source project is not a good idea. So requiring someone going to the repo who wants to just build this thing to have to do additional tooling wouldn't be fair. So that's why we wouldn't do that. That makes a little bit of sense to me. But back to the original thought. Do we release this and we add effet holes and we come up with a secondary solution in anticipation that there's a low likelihood that the first version of this is going to work? I'm okay with that. We're not under ton of time constraint right now, but I would like to wrap this up pretty quickly. It's the problem with hardware engineering. You get 99% of the way there, and it's that last 1% that takes 99% of the time. But it's worth it because you make cool stuff. So if I was a software engineer, I would just be compiling. It's not as fun. All right, we're gonna add effort holes. We're gonna use the original design, and we'll see if we have to worry about this later. But we'll have that secondary option ready to go. Okay. All right, so we're gonna implement the previous version of that latch design, and ideally we don't have to recalculate this. This is where we did that calculation. I remember now. So what's changed? So S equals R theta. R is the radius, which is now 125. I think S was the arc length, right? What was S? I forgot. S is, I think, arc length. Yeah, arc length. Why did we supply arc length? I think, oh, we measured from here to here. And then we wanted to know what theta that would be. I remember now. All right, that makes sense. Okay, so let's get that arc length. I think there's a way to brute force this. Actually, let's step back and slice our geometry, because we're gonna just replicate this on both sides anyways. So we'll pick that barrel midplane, and we'll know that we'll mirror this back over. We'll clean this up so that the start of the part is where we know we can step back to as we work through this prior to the mirror. So let's get that arc length. So might be a quick way to just brute force this, which is to guess it would be this distance. Yeah. $82. So we actually don't have to calculate anything, I think. We're gonna just add 82 to the end of this. Now we're gonna flatten this. I think we're gonna flatten this. All right. Never mind. We don't have to do these calculations again, I think, because we're gonna just flatten this. Right. Okay. That's changed. I remember now. So we still do need to model this though. So I'm going to pick up a midplane here to keep some symmetry about this screw. So it looks about right. And then I'm going to add a plane here that I'm going to mirror about that midplane there. And then slice this body. That's going to give me something that looks reasonable. I'm going to put the barrel midplane into construction geometry. So I know what I can quickly delete here. And so then, I think we said it was 48 degrees or something like that. And we'll just carry this through. So I'm going to isolate this. Well, let's. I keep forgetting that I have the select through tool. So I gotta stop isolating stuff. Start doing this correctly. So this, I think, was 50. Yeah, and if it's a little too long, that's fine. And actually, this needs to come out of here. Resulting body would be invalid. Oh yeah? So that works. Let's give it 5. Invalid? Why? Weird. Very weird. I think it has something to do with that radius. This one should work. Is that enough? No. This is not engineering, this is pure guessing at this point, but that's what prototyping's for. So we want that to be tight because we want to enable as much clearance as possible for the flexure to fit in. Okay. All right. So that strap comes all the way down. I do think we can pull this up a bit. I don't know that it really needs to be that tight. It also does not look orthogonal. So I might just slice this brute method style. Not slice, subtract. There we go. Alright, that gives me, I don't know if I would call it warm and fuzzies, but it does inspire a little bit of confidence. And then we'll add a tab like we have here. And as a matter of fact, I think we can actually literally copy that tab. So I do want it on the other side. And I do want it at the right angle. And it's on the wrong radius. So maybe I did this incorrectly. Let me see. I think that's right. Right? Let's get in there. All right, let's see what this angle is. Yeah, this is all over the place. Let's forget this. I'm gonna just manually model this, which is the right way to do it, but I guess I should be doing it the right way. So I'm gonna model this by just picking up that orthogonal face right there. Yeah, and just brute forcing this. Okay. Then I'm gonna revolve that. Actually, no, I'm gonna change the sketch a bit to make this a little bit easier to get my cutting relief on, which is what I should have done. So that cutting relief is going to need some space here. Now, let's get the correct thickness in. Just give this 5. Now we revolve that. This is going to be the thickness, and this will be 2 times the thickness because this is a bend on the outer. Some radii on the outside so you don't cut yourself. Okay, so that should be our locking flexure. Should be. Cool. So we'll be able to try that out. Hopefully it works. So now we'll need our effet holes as well. Where do we want to put our effet holes? So how many do we need? To properly constrain it, you could use something like the 3-2-1 method, but this isn't super high accuracy and not that critical. Yeah. If you ever want to know how to accurately locate something, especially if you're machining something, look up the 3-2-1 method. An absolutely insane person told me this a couple of years ago. I always knew how to do constraint design, but this was formalized in a way that the old graybeards would talk about it. So it's fairly interesting to know. But yeah. So there's the latch. We want to locate a potential solve. And before I forget, this looks like it's going to crash. No, just barely. Alright, so we need effet holes. They don't have to be perfect. Really, you just need 3 holes. 2, so 1 isn't enough because you can rotate. 2 would work, but it's not ideal because you could bend it about you could bend apart about the 2 bolts or the 2 screws. 3 would be just right. Would be properly constrained. We don't need more than that. So I'm going to do this in a very ugly way, and you are not allowed to judge me for this, but I'm literally just going to copy these bolt holes over, and yeah, use them to subtract. Very ugly. Does it look about center? Why not? Why not? Actually, we'll do one more. You know, parametric modeling is kind of a nuts. When you see stuff like this, but it's really good at just roughing stuff in. Whenever you're roughing stuff in like I'm doing currently, it's just phenomenal. It's like sculpting out of clay. I think these have to move a hair. There we go. There's our 3 holes. Those are our effort holes, so we can mount a secondary latch detail in the future should the one that we currently have modeled not work. Okay, and now we can delete this. I don't think we need that anymore. This I think we said we wanted, but I'm not sure. And this I think is annoying me aesthetically, so I'm going to fix it. Actually, it might just be an artifact of the rendering. I'm going to leave that for now. This, we'll redesign that later. Alright, so we have our effort holes. We have our barrel diameter increased. Screw clearance attachment on flanges. Change the slot details to increase assembly ease. Okay, these clearances here. That's what I'm talking about. This is annoying me, so that's going to go to 2. Actually, it's going to go to whatever this is. What are you? That should be 2. Actually, you both should be 4. It still annoys me, but it annoys me less. So we have slots here. That's good. Is this slot enough? I don't think it is, because it was radial. It was radial that was not radial. I'm sorry. It was circumferential. Is that a word? Yeah. Circumferential tolerancing that led to these being a pain to install, and the slot is perpendicular to the circumference of that, which doesn't really help us. Helps with install, but not in circumferential positioning of the hole. But the problem is if we open it up, then you could have it be sloppy enough that it's all a problem. Okay. All right. I'm gonna save this for tomorrow. We made good progress today. It's looking good. I mean, it's almost there. It's almost there. I'm going to be very happy if this increase in diameter makes this barrel methodology, manufacturing methodology work, because it's way cheaper. And it's almost arbitrary in cost to expand the size, which is fantastic. So I'm excited to get the next version of this prototype. Okay, thanks for joining. See you next time.